Hello again. It's been a while since I posted a video on my channel. Sorry about that. I've been kind of ill. I had shingles for a while and I can't really do much at like the tail end of the ray trace videos that I created late last year. Um, but after I got over shingles, I went dead for a bit. Well, I've been pretty busy playing around with things and being depressed about the election. Oh well, enough of the election. I'm I'm always going to be depressed about it. This is probably going to be another terrible 4 years like the previous one, but who cares? This video I'm going to cover is I did some experimenting today. I decided to take a look at kind of a little versus challenge. Um, I've been looking at two different engines, Godot and Unity. Godot, which I've never used before, and I just kind of learned it today. And Unity, which I've used it quite a bit. And I wrote the game from scratch too, as well, to demonstrate the differences between using an engine versus coding from scratch, such as using Unity or Godot to create a game, versus utilizing OpenGL and writing all your logic in C++ or using some sort of scripting solution such as Lua. Excuse me. Um, the game example that I've used in this kind of test little kind of test scenario is Pig and Sticks. Again, Pig and Sticks is a great game. It pretty much it allows you. It's a game that basically it's kind of like a Hello World program, for example. It does very low basics. Thank you, Rachel Moore, for creating it. But mine's gonna be fairly way simpler because I'm not adding a scoreboard or the kind of text list from the past. I'll post links to Rachel's videos about which their old videos are made like 10 years ago about the subject. Let's see here. Um, and I recreated every single the same game in both Godot, Unity, and from scratch. The one from scratch took a while. Yeah, it took 4 hours. But for starters, let's do a little kind of test. I want to see how much memory these projects kind of take up. So let's see here. Release Godot. Let's run it. Put you over there. That's the end product, what you're going to see on the screen countless times here. Let's look at the memory. It's using about 64 megs, which is not bad. Let's click some sticks, see if the memory goes up, make sure there's no kind of like a memory leaks going on. It runs pretty well. I'm trying to figure out if Godot is using like linear filtering for the textures, because in my on the one I made from scratch, I'm using the nearest filter. Basically means that it just shows every pixel on the screen. But yeah, it runs pretty smooth, which is a good sign. But then again, this is not a really resource intense game. So yeah, 64 megs, not bad. Okay, let's go to good old Unity. And let's run the Unity one. Now, I'll show you something interesting about the Unity one in a minute, but let's just run it for now. Get down there, open that. Alright. For the Unity one, right now it's running 35 megs. I know the reason for that. I'll tell you in a minute. But let's just run it. It runs a little slower, but there's actually reasons for that. It has to do with how you create 2D games with Unity. Excuse me. But the thing about the Unity one is if you're watching like the PNS kind of excuse me process in the task manager, it looks like it's having a memory issue. But then again, this is an older version of Unity, so it could have a memory leak or two. I don't know. But yeah, does the same thing. Kind of. I'll show you what I mean by kind of once we go look at the projects. Alright, it's done with this one. Okay, I forgot to do something with the Unity version of the test code. I'm sorry. Here it is. If you go to pick the Unity version, this is one big advantage it has over the other two projects. You can set the screen resolution. Now, if with the other two projects, if I would have set the screen resolution higher than 640 by 480, it's going to do some weird stuff with the screen and it's going to appear smaller. But because the Unity version uses independent coordinates, you can do something like this, play it, and it just runs. This is at 720p. And let's exit that. Let's go to 4. And this is at like 1440, 90, or say 900p. Now my monitor can handle, it's a 1080p monitor, so it can go up at least that high. Too bad I don't have a 4K one, but this gives me an interesting challenge for like future projects, because I want to make it, if I'm going to do say 2D projects, I want it to render at a lower resolution, but I want to upscale it to a higher resolution. And I'm probably going to borrow that idea from Unity, because this looks very nice. Well, sorry I forgot to show you the kind of advantage that Unity has over my engine so far. And yeah. Now let's go to the one from scratch. And over there, you go right there. Put you down because I don't need you. Now the one from scratch does use a little bit more memory, but as you might have noticed, it's running a little faster in some ways. I think I'm also recording this at 60 FPS too, so Now I will tell you I will tell you what rendering APIs I'm using for each project after I get done with this demonstration. It's running pretty good, not bad. It's not wasting any memory, which is a good sign. So there's no memory leak. I guess I'm good enough coder to make sure I don't have memory leaks in my code. So I don't overly abuse a heap at all, which is a good sign. Okay, it's running nicely, and exit that. Now, it did use a little bit extra memory. The reason for that is that Godot uses OpenGL ES 3.3, and which uses less memory than what I'm using. I'm using OpenGL 4, so that's why I'm using so much memory. I'm using so much memory in the one from scratch. The Unity one, on the other hand, I think it uses Direct 3D 11, if I remember correctly. Okay, so I guess let's take a look at each project. Um, the Godot one, let's open this. Hopefully this won't kill my computer. This is the first time I've ever used the Godot engine, so I'm still new to it. It's weird. It does things that I don't quite understand. I haven't used it as much, so this was kind of a learning experience. It reminds me of Unity somewhat, but it's still a little bit different experience. Um, for one, I actually really do like the 2D game engine, the Godot's 2D game engine. I've never touched their 3D engine yet, so I can't really give any judgment calls on it, but I really do like the 2D engine here. Um, let's look at some of these scripts real quick. As you can see, I have manager class, which has a script. What this does, it initializes the sticks, and then it adds them to this stick manager, which if you look at the kind of stick TCM, or should I say the script, here it is. Yeah, this reminds me of Python. Basically, I kind of messed up because I don't know how to get the kind of window coordinates yet. When I get more experience with this engine, which I'm probably going to use it some more for some other projects, just being playful with it. But yeah, it's pretty easy to use. I'm kind of shocked by it. I was pretty surprised by that. One thing about engines that confuses the crap out of me is I don't typically use kind of like a scene graph in my games. Typically, I kind of just write them willy nilly, and then I add in a manager to handle multiple objects. Here, they use a kind of a scene graph or kind of component system thingy. I'm trying to figure out how to do this in my own code. I'm still confused by it. One of these days I'll figure it out, but what am I doing? Well, the difference between my code, which is straight C++ code, is that they use kind of like a Python variant language thingy, which kind of it was kind of a learning curve because I was trying to figure out how to do internal classes, and for some reason I couldn't figure out if there was a constructor for this, which kind of confused me. And I'm getting old, so I get easily confused. But it's pretty straightforward. The ready function basically initializes this particular class, and the process one is kind of like the heartbeat or update function, which has a delta. The stick basically gets the player, and it does some collision testing, which I use this rec class to do it. I probably should have used the internal physics engine to do it, but nah. This I was just testing to see if this will work or not. The player is very basic. Um, it will just randomly appear anywhere on the map, and then it will just do some input stuff, and it will move correctly if you run it. And this program, it does the same thing. The only difference is that it's debugging it instead of being released, so it's actually running very fast and but debug. Let's look at the memory profile on the debug version. Do do do. Where are you? I don't know where you are. Alright. I guess I am getting old. Oh. I'm assuming it's that one. Yep. Yeah, it was that one. Let's see here. Yeah, it's not a bad little engine. It's similar to Unity. It basically uses nodes and that sort of stuff. Man, yeah, I was generally impressed with that. So let's move on to Unity real quick. Quit. I'm gonna put you down there. Unity, I have to open it right here. There we go. Okay. Alright, now we're in the Unity version. Let's take a look. Alright, let's run it. And it plays just the same as it did before. However, there is a very big difference between Godot, the Scratch, and the Godot and the Scratch version versus the Unity version. Now, the thing I forgot to mention about the Godot version, you can use window coordinates with it. Basically, you start from 0 right here, and it goes to like 640 on the width of the screen to like I guess 480 on the Y. With Unity, they're using screen independent coordinates. However, it's not arranging kind of Windows coordinates at all. Like for example, excuse me, the player right now is at 0, 0. Watch this section over here. If you move the player up, which in Godot and in the Scratch version it would be negative, instead it's going in the positive Y direction, which I think it has something to do with the camera's viewport. And set it back to 0. Go this way, it goes negative. So yeah, that's one thing that kind of confused me about the Unity version, even though it was actually the fastest one that was made. Because I based it off the Godot version. And the other thing is, I had to do some weird stuff because I had to scale up everything by 4. And I had to put the camera like 9.6 times the size of the screen. It was kind of weird. Very, very strange. But it works. Like the previous version, there's a stick manager, and it basically initializes sticks. So if you look at this script right here, real quick. Oh God, it's gonna have to load. Sorry about this. I'm gonna do a little bit of video cutting. Oh yeah, y'all, I do have a test channel that was doing like Minecraft Let's Plays on it. I was using that to basically learn how to do video and just help me with my voice problem. And I kind of solved a bunch of things. As you can see, I'm talking a lot more clear than I did before. And I'm a little bit more confident in doing this. So come on, prepare solution. Open up Visual Studio 2015. You're so slow. So yeah, I'm improving over time, and I'm more confident about this. Okay, there we go. Sorry about that wait. No, just stop. All right, as you can see, this is the stick manager mono behavior, and it's in roughly the same thing as the Godot script. It basically initializes a new game object. Then I got the stick script from it, which I'll show you that in a minute. Then it sets player. No. Let's go back to Unity real quick. This one. Sure, why not? I don't care. Now, the game object is used to basically track collisions, and I had to create another rect object because, well, I didn't want to use the physics engine, like, because I wanted to keep this game as simple as possible. Excuse me. Now, because of how weird the camera system is in Unity, I had to do some weird stuff with positions for random. Thankfully, the random number generator in C Sharp's the .NET framework has an amazing range function, which I love, and so I can go between the screens, kind of min and maximum on the screen randomly, which helped me out quite a bit. It does basically the same thing, for the exception I had to do a little bit more boilerplate code for this because I had to transform this position attribute. I think it's what it's called, a parameter. I'm not really sure. I'm still kind of new to C Sharp. You can't just set the kind of X value in this. You have to you have to basically set it as the object because the float value itself is a value, not a reference. Oh well. I'll let that go. And the player going here is basically the same as one for Godot. It does roughly the same thing as that Godot script. And yeah. Now, I am actually kind of amazed how quickly I got the Unity version of it done. I got it done like I think maybe an hour, where the Godot one took about 2 to 3 hours due to the simple fact I didn't know Godot at all. I knew Unity a little bit better, but it was kind of amazing how quickly I got this project done. It was a lot faster, even with the kind of weirdness with the camera. I think Godot has a better kind of 2D game engine compared to Unity. Unity is more of a 3D game engine. I think it shines better when you're doing 3D with it. I'm still kind of weirded out by it because of how the camera works in it. But yeah, this is the Unity version of this PNS game, all the source code. Do I have any additional source code for this? I don't remember. Not really. And the funny thing is about the Unity version, it uses less resources, which is kind of hilarious. Um, and like I said before, the reason why it didn't have as much memory is that it's using DX11, and on my computer, when I was doing Direct3D 11 kind of test, it doesn't use as much memory as OpenGL because, well, it's Direct3D is a Windows thing, and it's optimized for Windows, which kind of makes sense. All right, moving on. Let's get out of this program. The longest. This version took about 4 hours. And there's a good reason. I had to write everything from scratch, including a bunch of things. I'll show you in a minute. I basically had to write a small framework to get everything up and running. The code's a little resty because I writ a lot of the kind of system code inside the main source file, which I'll show you in a minute. Well, this is 2017. It loads faster than 2015. So, come on, load, my friend. Yes, it's way shorter. Disregard that mess down there. That's official glitch. Come on, load. There we go. And here's the Scratch version. A lot more code. Got a system up here. A lot more code. I had to basically write some functions for the Windows stuff, which I'm using SDL2 for. I had to wrap up the input API, which I actually like this new way of doing it. When I make input APIs, I typically have like release down, press, then up. This actually makes more sense because technically I want to check for if it's pressed once or if it's released once. It kind of makes more sense that way. And I've also implemented a pretty nice way to do key binding. Typically, I usually throw a keyboard interface that wraps the SDL scan code, but for this one, I decided let's be lazy and just use the SDL scan codes. Alright, the longest thing that took forever is the renderer. If you have ever done like OpenGL programming at all, or Direct 3D programming, and if you want to basically sink into a bottle of like Jack Daniels or something doing Vulkan or Direct 3D 12 programming, yeah, the renderer takes a while, and this took me about 2 hours to create, which I'll show you in the main function here, because all the Windows stuff and the input interface took me like 30 minutes at most to create. It is this damn OpenGL API that took forever. It's because you have to initialize a whole bunch of stuff. I am using OpenGL 4, so you have to initialize like all the shaders, the program, the vertex array, which kind of acts like at the top of the graphics pipeline. It basically enables whatever piece of data that that you're going to use for the renderer for like the pipeline. You also have to grab all the uniforms and attributes, and if you're using UBOs, the UDBO block location as well. And I decided to create some simple buffers for this, and just kind of kept them around, which is the vertice buffer and text chord buffers, and I'm storing textures. Yeah, textures. Yeah, this took a while to code. And this is why it takes a little longer to get a game written from scratch if you're using something like OpenGL. It would take even longer if using Direct3D 11 because it has a little bit of an initialization thing with it. I'm still not used to that API. I miss Direct3D 9. It was so easy to get it up and running. And yeah, this is the system side of everything, which is kind of part one of the scratch code that you have to write. And you have to write up the entire sys layer from scratch. Then you have to write up the game, which really didn't take that long at all. It took about the same amount of time as like the Unity project because I've done this so many times. Create some key bindings here, loaded up all the textures that he needed. I decided to make a level object. If you go to sys, the level object basically is kind of like the game's context object. because I pass it around to get information about the player and the sticks. It's a very easy way if you're going to make small games. Doing something like this makes managing the code a lot easier. Excuse me. Rectangle. Same rectangle object. Simple collision detection. The player object does structure does basically the same thing as it did in Godot and Unity. It's fairly the same code, for the exception I render in the code as well in here. The stick is basically the same too. Some of it's a little shorter because I can do some stuff with C++ you can't really do with C#, which is kind of strange. You would think C# it'd be easier to do things, but nope. And the stick manager does the same thing. I love C++ lambdas. I love them. They make my life easier. And the kind of level object basically is just kind of like a context that holds everything. And yeah, that's pretty much all the source code for the Scratch project if you run it. Yeah, yeah. I think they are using a linear filter. Okay. Yep. Yeah, I confirmed it. They're using a linear filter because if you remember from, I'll just run the Godot version at the same time just to kind of slow it down a little bit, but No, 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 no. Release. Let's do a little comparison here. This would probably be evil because I'm running two games at this. It's okay. It's okay. You go here. I'm looking at it. Yeah. Yeah, look. Mine's running a little slower, but Yeah, they are using bilinear filtering. Ah, interesting. Cool. I think this is it for this video. It was a fun little experiment. The other thing that I was working on, this last part of the video is just going to be a news update, is I've been doing a whole bunch of other projects. I've been learning C#. I did some kind of direct 3D stuff. Well, this is a kind of an interesting example because I was doing some path stuff with Direct3D 11. I was doing stuff with Direct3D 11. Dude. Also made a first-person shooter project too. Oh, this is actually kind of cool. I forgot I made this thing way down there. Yeah, I forgot. I was doing some Direct3D stuff. I think I stopped doing it because I was playing around with entity components. Also did some games with it. I think this is just a Pong. Direct3D 11 Pong. As you can see, I am running Direct3D 11. I think this is just Window API code. As you can see, it's just 4 megabytes. It's like nothing. It could be SDL, but let me show you something about those. What are you? Oh, you're nothing. All right. Now this is using SDL, I believe. Yeah, it's using SDL. Let's just run the mesh one, which has our mesh friend here. It could be SDL causing it because there is a layer. Where's run? What's this was the mesh one mesh. 7 megabytes. As you can see, DirectX 11 uses way less memory than the OpenGL one. If this was OpenGL, this would have been about maybe 30 megs. It could be. I don't know. I don't know. I don't know. I really don't know. Oh, it just jumped up to 11 megs. I wonder if I have a memory leak in this code. Yeah, that's some stuff I was been doing. The other thing I was doing, which I'll show you, is this Big Mess project. This is a first-person shooter game, and I'm gonna play it before I leave. It's probably gonna run like poop. Here it is. Yeah, this is what I was doing when I was depressed during the whole election BS thing. I did this entire thing. So yeah, I was very productive. I worked on this in like 2 weeks, which I'm probably going to release this as kind of a joke. Yeah, I had some fun with this. Some really choppiness. It's probably the video. Play with this. And it does act like a shotgun. I had a lot of fun making this. Dang it. Ah, the choppiness. Yeah, I'm probably going to release this for fun. I figured out a number of things, like how to make sure the gun doesn't go through the floor. You have to basically clear out the Z buffer or depth buffer before you render it. You render everything else first, then you get rid of the Z buff, then you clear it, then you render the weapon. Ah, crap, I don't have any bullets. Die. And yeah, I hope you all enjoyed this video. And if you want me to explain any of the stuff I've been doing for the past few months, I don't mind making another video about it. And I'll see you all in the next video. Y'all take care, and I'll see you next time.